The conclusion we've come to from that is that there's a significant spherical aberration appears to be present in the optics.
And that we should be able to fix it in our insurance program.
Chaos and confusion after the Hubble mission. There was threats about shuttle coming to an end because NASA didn't have the capability anymore.
And we have a go for main engine start. 5, 4.
We couldn't do this, we couldn't do that. Hubble was a disaster. None of this was in the books.
Liftoff. Liftoff of the Space Shuttle Endeavour on an ambitious mission to service the Hubble Space Telescope.
My boss on Orbiting Astronomical Observatory, he said, look, I'm going to form a team to design a new telescope. We don't even know what we're going to call it, just a large telescope. And I want you on that team, and I want you to go work the mechanical system and figure out how we can take advantage of the new space shuttle program to see how we could launch it and maybe, if necessary, repair it and upgrade it. And we built a full-scale mock-up over about a 4-year period from 70 to 74. And we came up with what was called a modular concept. We designed the instruments and stuff, the complicated parts of the spacecraft to be modular so they could, interfaces could be simple, and the modules could slide in and out and be picked up by the same standard interfaces. In 75, they picked a winner, and the winner was Marshall Space Flight Center and Lockheed. And so we were essentially out of the business, other than to consult with them with regards to future servicing of Hubble. We were responsible for the instrument development, which by that time we decided they were going to be differently modular instruments. So modularity started to creep in the thing. And then the third aspect is we were responsible after launch for flight operations of Hubble. Right after the launch, and they discovered we had this aberration, then I got approached by people at headquarters saying, hey, would you be interested in doing a servicing mission on Hubble? And I said, yeah, we've been practicing. We were ready for that. We had to figure out what had caused the optical problem. And at that time, there wasn't a sure answer. What's caused the spherical aberration and how bad is it? What are the optical constants that would allow us to correct? So for 6 months, from August on, we focused on the problem, that one problem.
We indeed are a privileged crew to be able to fly on this mission. We have had some of the most intensive and extensive training that I have ever experienced in preparation for a space flight. That started with crew members being named early. It continued with the use of resources and facilities that had not been used before in the development of the plan and in the training of crew members.
We have trained to be able to work with different people. We have also done a lot of training.
The differences between the kinds of training.
We'd be very happy to stick with what we've been training to do for a while.
Indebted to the tool folks here at JSC and up at Goddard for not only giving us the tools that are very EVA friendly, but actually modifying some existing tools as we went through training.
The astronauts figure out things, they see things there that they figure out what to do in case something happens that's not going right. They figure out what to do. Training opens your mind up to doing things other than what you would normally do if you had to have a reverse way of doing it. If you couldn't do it the way it was planned, here's another way to do it. There's always this part about training and testing and so on that allows you to find the other alternatives. These missions didn't go perfectly. Day one, boom, 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 boom. No. Almost every day was a horrendous fear challenge. We didn't plan for failure, per se. We planned for what if this didn't work, what if that didn't work, what would be the backgrounds to augmenting that failure, or leaving that failure alone and just going past it. And we did have that. We did have backgrounds for almost every one of our EVA integral missions. That if we didn't do this, we would immediately skip and go over here to this, while the engineers on the ground would figure out what to do there. We would not allow ourselves to think of failure. And now every one of our missions, 100% successful. Every mission led to 3 to 4 more years of future missions. Eventually, the astronauts and the water tanks, they got so comfortable with working with our mock-ups and stuff that they began to ask us for help on things like servicing station. So we were able to develop and change some of the tools, vary the tools, change their design so they would work on space station as well as Hubble. And so pretty soon, a lot of the tools that we were using initially on Hubble ended up being used predominantly on space station for space station servicing. And so that was a very important growth prospect there. It gets back to this concept of enthusiasm. It gets back to this concept of engineering management. And from an engineering perspective, you need basically to coalesce, to bring together a group of people with a common objective and keep those people together via communications, via large meetings, via whatever is necessary to keep them going. Hubble represents never say no. If something is tough, go for it. If it's worthwhile doing, go for it. Dig into it. Do not let no bother you. All these things, they can be solved. They can be solved. They can be solved if we make our minds up to go solve them.
This mission success was no accident. We told our people across the board very succinctly 2 things: that to be successful, we were going to do testing, and retesting. And as you can see by the images, they succeeded. We succeeded. The formula panned out. It's a formula which took 30 years to develop here at Goddard. We've evolved from that point to get even to a better technology today, and I think we move on from here into the future.